Hello? 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 We'll just wait for others to join in for a bit. Maybe when we get 100 people online or so, we'll get started. And also take note that today's exercise will be assessed. Okay, so seems like we're running out of time, and I can't take the chance that maybe some of the other classmates are joining. The link was shared. That is almost 5 minutes ago, and students knew that we are going to have this lab or practical session about now, and so I'll take it that maybe they have something else to do. So I'll get back to our folder where we are doing our labs, and so I'll create a new file, and this should be practical session number 3. So this is lab 3 and 2025. Okay, so about here, that's where I'll create our that's where I'll be writing our code from. And so let me just browse to that location. So that is labs and lab 3, and this is the folder that we're using. And so here I'll create a file, and I'll call this file methods.java. And in today's session, we'll be looking at methods and basically everything that has to do with the way we manage methods. So once again, we'll say public class methods to match exactly the way this class is named, and I'll do the usual thing that we do, public static void main, and this is string args, and then I'll do that, and I'll say system dot out dot println, and I say welcome to the methods practical session. We will explore methods in this session. And so like I've been saying, we need to always comment our code well. So here I can use my AI and just say add a block comment stating that this is a practical session covering the basics of methods, and so it will do a block statement for me. But of course, yourselves, you should get to write these comments. I'm just being lazy, which is fine for me, but not fine for you. Practice your comments. So this class demonstrates a practical session covering the basics of methods in Java. It serves as an introduction to defining and using methods. For now, this is sufficient. Let me start a terminal, and in this terminal, I hope the terminal opens in the current directory like VS Code always does. So I'm just waiting for the prompt there. Okay, so the prompt is taking a bit of time. Oh, great. So there we go. And so I'll say Java C. The name of this is methods. upgraded my poor computer. So that is javac methods.java, and we compile. We see if this will compile without errors. Okay, so it has compiled without errors, and then we'll now say Java methods. Hopefully it will print out the welcome to this practical session. Okay, so the most probable reason why this is happening is that the class path for this code is not resolving nicely. Let me try to do that first so that I can get to that location nicely. Okay. Still waiting for this. Okay, on account of time and trying to save on time and resolving this, I'll just go into my PowerShell directly, and so I'll probably run the two. I'll run the two on the one screen, and so yeah, so cd to the desktop, and under the desktop there's a photo that I go from, and then there's CSC 2000. There should be lab, and then there should be lab 3 2025. I'm there. Java C. What is the name of this? This is methods.java. Okay, and then we can say Java methods. Okay, so this has compiled. We can forget about this terminal, which is just taking our time. And we can close this, and then I can double click on this. Okay, so we'll work from here for today. It's fine. So what we're trying to look at today is basically methods, and like we said, the very first method that is called is the main method, and we can create a method, and we'll call this method public deliberately. We'll call this method public, let me say void. So public void display message, and say this is a message that displays. Okay, so we'll get this, which is the greeting that we're getting, and we'll add this greeting here in the display message. And then when we come to the main method, what we're going to do is call this method called display message. And so essentially what we're doing is what we're trying to do is call this method called display message, and when we call this method called display message, it will print what we're printing initially directly in the main method. And yeah, we're noticing the red wavy line below the method core itself. Let's ignore it for now and just come here and do a compilation to say Java um, methods .java. So you'll notice the error that will come up. So it says okay, so it says cannot find okay, so this is a misspelling. So this is supposed to be display. So it says that it cannot find display, which I've corrected to be display. Let's compile again, and this time it says error non-static method display message cannot be referenced from a static context, which makes a lot of sense because static methods can be called without creating an instance of a class, whereas non-static methods, which we call instance methods, can only be called when you have an instance. So this is a contradiction because main doesn't require an instance, but display message requires an instance. So how do you call something that requires an instance where you do not require an instance? And that's why we get this error. And the shortcut that most of you will take, and I cautioned you in class, would be to just say static void display message. And so we proceed then. Um, we proceed to to try this. I know that we now know a little bit about how object-oriented programming works. So I'll say methods aim is equal to new methods, and so then I can say aim dot display message, and because I've done that, then I can remove this, and so this should be the correct workaround because the method is an instance method. So what we need to do is to create an instance and use that instance to call that particular method. So I'll go back and do a compilation, and once I've done a compilation I run, and it gives us exactly what we want. So this is how you declare a message, and this is how you call the method. If the method is static, you don't need to create an instance. If it's a non-static method, then we need to use an instance. So here I'll just add a comment and say this is an example of a non-static method. To use this method, you need an instance, right? And then we'll create another method, public static display message without instance, so that the WI there is without instance. So we'll say system.out.println, and in this case we'll just say static method call. Okay. Okay, there's no return type, that is missing. So now we add return type, and that is fine. So for this one, we can easily just say display message WI, and this is a static method call. And so if I compile this again, this should compile successfully, and if I run this, then it should give us that call. So that would be the difference between the two. The one is a static method, the other one is an instance method. A static method, we don't need an instance to call it. So aim is what we are calling an instance here of the object method. And in the other case, a non-static method, we need an instance, and so we call this method using that. So let me just put an I there to show that this is the method that you call using an instance, and the WI there for the other method. So then the same methods that we have, we can pick them and declare them again. And of course, Java will not be happy with us because we have the same methods exactly and we're declaring them twice. You can't do that. And so if I say javac methods.java and I try to compile, you'll notice that the error that will come up will say this method is already defined in class methods. So we also discussed concepts that are related to method overloading and overriding, and we said method overloading is where we have the same message, but the same method, but passing it different argument sets. So if we get this display message and say this one gets a message that is going to be displayed, and we come back here and we say this one also gets a string which is a message to be displayed. The moment that we do that, then if we come here and we say javac methods.java and it compiles, let's run to see if there's a runtime method. There's no runtime method. So these two methods are different in that it's overloading, but this guy gets an argument and this guy doesn't get any argument. So we can as well just say here that we'll print out this message and not print this message that we had by default. And then we can also go to this other method and say let's print this message. So at the same time that we are discussing method overloading, we are also discussing a concept of parameter or argument passing. So you can pass arguments to a method and use them to do some processing of these methods. And so here we can say display. Notice that the call will be exactly the same, but this calls the display method with a custom message without need for an instance, right? And we can also then say display this calls using an instance, and we can save this and we can come back and do our compilation, and after our compilation we can run this, and so it will tell us that here to say welcome using a static method. Here we're using an instance, and this calls without need for an instance, and this calls using an instance. So we've overloaded these methods, and other than overloading, we've also explored the concept of passing arguments or the form of parameters to these methods. And so another interesting thing that we can do actually is, let's come here and create this variable to say private static string message, right? And so we've got this guy called message, and so what we are going to do is come here once again and compile, and then we notice that if, for example, I created something like string message here, is equal to this message, and then I do this. So let's try to compile this first. Um, so if I compile this, you'll notice that I'll be told that the variable message is already defined in method. So this is because there's this message which is here, and then we are redeclaring the same variable here. So this message and this message will cause this compile time error, because we're declaring the same variable twice. Now let's try to delete this, and remembering however that we still have this message which is up here. Notice the spelling is exactly the same, right? And I come here and I do the compilation once again, and then I run, and bravo, Java does the compilation, right? And so this other guy is working because the other um, uh, the other message variable is declared as a class variable, right? And so if we have a class variable, and then here we declare the same variable inside this display message, what happens is that the one that is inside the method, which is scoped within the method, will override the class variable. So this is a local variable. It is local to this method, this string message, whereas this other one is a class variable. So the local variable here overrides that guy. So if I wanted, I can say system dot out dot print line, and then I say this dot message. So let's get that guy and make that guy an instance. So I'll get this one, and I'll cut, and I'll take it to the one that has an instance. So if I do that, this is a class variable, and because it's a class variable, we expect that if we say this, we are calling the class variable, whereas when we say message, we are calling the instance variable. So let's try to do the compilation again, and then we run. So you'll notice that we've printed this message twice. So here it will say this code displays this calls the display method with a custom message without need for an instance, which is correct. This is this message, and then afterwards it does that one which says welcome to the methods blah blah blah, and this is declared as a class variable. This calls the display method with a custom message using an instance, uh, which we have up here. So declared as a class variable there. So this is this guy that we have here, and so the main thing that is there is that we have overridden the one that is in the that is the instance method, and if we want to access it, we can use the this keyword to say I want to access the variable that applies to the class inside this method. And if we don't do that, if we just call it, then we are using the local variable, which is method. So that is how we do so that is how we do the passing of variables to method. Then, other than that, methods can also have a return type. So we get this method. Let's get this one that has no instance, and then we redeclare it, and we just say return type RT at the end there. And what this guy returns is a string, and that string, we just get the message that we received, and in this case we say return, we say return and we say modified message, and we say plus this, and then I remove this. So this calls the display message RT, but this message returns something. These were returning void. However, this method returns something there, and so I'll call the same method and just say it's an instance method, aim dot and say display message RT, and message call to return. Okay, so I'll accept this change so that we print out what this guy is returning as we return there. So we go back here and we say again Java C methods.java, and afterwards we say Java methods. And so you'll notice that this is a modified message call to return. So when we call m.display message RT with this message, we pass the variable to this message, the argument, and then we add the text there. This is what we return, and that's why we have to call system.out.println. So this is a return type of a method. Every method needs a return type. So we need to pass in something, or if we're not passing something, we just leave it with the braces like that. Or if we pass something, we pass the arguments like that to a method, and a method will always return something, and if it doesn't return something, it will be void. Otherwise, for example, here we are returning a string. If we so wished, we can also pass multiple parameters to a message, and we'll get this same modified message, and we say string name. So here we'll then say return, we say hello, and then we say plus the name, and then we can say plus, and then I do a /n so that it takes me to the new line, and then plus modified message. So say Java C, that is Java compile methods.java, and this does the compilation. Okay, so I've got a bug, so I didn't modify this so that it takes the second parameter, and then so I'll give the second parameter as Mayumbo Nyirenda. So Java C methods.java. Okay, that compiles now, and then I say Java methods. Okay, so at the end there it says hello Mayumbo Nyirenda with a line feed, modified message call to return. So you can pass as many parameters as you wish. and um, so you can then pick them within the method and use them. The methods can pass in um, they can pass in primitives, they can pass in objects. The same way that they can also return primitives, they can return objects, and so on. So you can do all sorts of things in methods. Inside one method, you can also call another method. So for example, here we say public string generate message, and so generate message, you get a string called message, and then it will also get a string name, and then once it gets that, what does it do? It basically does this, and then does that, and then for this one we'll say return generate message that and that. So what happens is that so we get something like a message here and the string, and then once we get them, we also call this method. So this method will return something which we also return to this method, and we then have a message being called within another message. So you can compile this and check what this is doing, and it gives us the same thing. So there are all sorts of things that you can do with methods, but they are built around these simple concepts. They'll have a name, the braces, arguments to pass to them, which can be arrays, strings, objects, primitives, etc., and they'll return something. And you can have multiple messages, not messages, multiple methods that have the same name, but then they have a different parameter set that they're getting, and we call this method overloading. It can still wake. So we can also do that test for ambiguity, so which returns an int, and then we say test ambiguity. I hope that's how you spell ambiguity. So it gets int a, and then also gets int b. I think we discussed this in class. So this method gets to integer, and what it retains is basically a plus b. And so here we say let me queue all this, because it is giving us too much output and we can't track what's happening nicely. So I'll comment it out, and after I comment it out, okay, AI has failed me. This is not what I wanted. I wanted to comment this out. Laziness. Okay, that does that. So then I say system dot out dot println aim dot what did we call that method? Test ambiguity, and we'll pass it 2 and 3. Okay, great. So let me clear this and then say Java C once again, methods dot Java, and it compiles, and then I want to run it. Okay, so we'll come to the methods. Then the sum of these two. So let's just say here, to make this more interesting, then we say the sum of plus a, and then we say plus b, and we say is, and then plus. So I'll need to do this. Okay, so this is exactly what I want to do. So then I'll say java c methods .java and compile, and then I'll run. So then it will say the sum of 2 and 3 is 5. Fine. So now let's test ambiguity. We notice that if we get this, and then for example I say string b, and then okay, so string b won't work. Okay, so let's say let's go direct what we want to do. So we say double b, and we return a plus plus b. So for this method, let's also modify it to say it returns a double, so that this is also without any challenges there. And then we also say double, and so we have two methods. This returns a double, and it gets a and b and does the addition, and we print that out. So these are exactly the same, and so I want to compile this. And then afterwards I want to compile. So now the question that is there with this ambiguity is, which of the two methods are we calling actually when we call this like that? Because we can call the one that picks without a double but with an int, and it will work. So I'll do this to prove the point. So I'll run this, and then I'll do this. It's working, right? And then I'll also do this, and this, and this, and kick this out, and I'll kick this out, and then I'll save again, and then I'll compile, and I'll run, and once again it works. So we've established that both can work with that method call, but then the moment that we do this, the question is, which of the two do you think is getting executed? The one that is picking an integer and an integer, or the one that is picking a double and a double? So we want to avoid such ambiguity, which is quite dangerous for your code. So if I put multiplication here, and then I do the compilation again, and then I run, and we notice that we get a 5.0. And so if we then force this and say 3.0 and do this, and then I run this, so then you notice that then it returns 6. So this is quite ambiguous, and you don't want to have this in your code, because somebody will call this like that and it will work, and they'll call it with this and it will work, but which one is being called at what point then becomes a tricky thing, because both of them, even if I was to comment this out, this would get called. If I comment this out, this will get called. So please, when you're doing overloading, avoid such ambiguity, which can lead to all sorts of errors and misinterpretation of code. So that ends the activities for today, and what you'll be required to do is to write code that basically is similar to the code that we have here, and then I'll give you some questions to answer on Google Forms, and then that will be your submission for the lab. Unfortunately, I know that we can't pick any questions in this class, because of the approach that we are using for this class. So I'll share the activity and then you can go through it, and we'll meet for the next practical session next week. Maybe what we can do is before we start class, we have a Google Meet before we start the practical sessions, and people can ask questions based on the previous lab, and then we proceed into a YouTube live stream for the class for that day. Alright, so this is the end of class. Thank you very much for your time.